Students, we are discussing the conversion of analog data into digital data, or in essence, the process of digitization. Students, PCM technique जो है, pulse code modulation, which is the first technique that we were studying to do that, उसकी discussion हम लोगों ने complete की थी, and now we are going to talk about the second most common technique, which is called delta modulation. Students, PCM, as you must have guessed by now, is a very complex technique. Sampling is a complex process. Sampling introduced errors when we studied it. You saw that quantization, once again, is completely based on approximation. Yes, we do have some mathematical baselines and formulas that we normally use, but it still introduces quantization errors. Students, once again, encoding, the choice of the code word and the basis of the encoding that we are going to use to produce these code words is very important, because that can produce more errors. PCM in general is a complex technique. Students, multiple variants were presented, and the most easier to use non-complex version of the analog data to digital data conversion technique was the delta modulation, or DM. Students, PCM mein we work with the different pulses, and we work with the amplitude of each one of those pulses or samples. Students, DM mein delta modulation mein we find the change from the previous sample. So we see that what is the pulse, what is the signal doing from one sample to the next, and based on that we try to create a delta modulated signal of that analog signal. Students, the noteworthy thing is that there are no code words in delta modulation, and you will see that in an example. We actually send a stream of bits as it is. We do not divide that. We do not distribute these bits into distinct code words. What you can see is the process of delta modulation. Students, इस केस में जैसा कि मैंने आपको बताया कि delta modulation uses the change from the previous sample, and based on that it actually produces a particular DM generated binary signal, and from that signal it creates a binary stream of bits that is then sent to the receiving end. Students, the first bit out here, we start with a 0. Now, as you can see, that our amplitude is increasing. Our amplitude is continuously increasing. So the next bit is 1. It's still increasing, 1. We are still going up, 1. The amplitude is still increasing, another 1. We are still increasing. As of this point, we are still increasing, so we have another 1. And the last increase as per the quantization level on this side is again a 1. Now, what we see is from this bit onwards, the analog signal is actually, the amplitude is reducing. So we come down and our next bit is a 0. The amplitude is still decreasing. Next bit is a 0. Still decreasing, a 0. Still decreasing, a 0. Constant, a 0. And it slowly starts rising up. So we have got a 0 here, and then goes up again. It's still increasing, goes up again. So for every decrease in amplitude, when I told you that it finds the change from the previous sample, then let's take an example of this bit out here, because this is normally the most confusing when I'm talking about delta modulation. So as you can see, it takes it from the previous sample. There is a 1 here, because in the previous sample we are still constant or increasing. So the next one is still 1. Now let's talk about this bit out here. Why is this a 0? This bit will be a 0 because when you look at the previous sample, which is this sample out here, this sample, the analog signal is actually going down. It's decreasing. So the next bit is going to be a 0. In this particular sample, it's still decreasing, as you can see. Next bit is going to be a 0. So this is the process of delta modulation. Once again, DM finds the change from the previous sample, and there are no code words here, but this generated binary data that you see out here, that is sent in the form of bits 1 by 1.